So in this short video I'm going to show you how to find the standard deviation from frequency tables. One will be grouped and one will be ungrouped. So we'll start with the simpler of the two, which is the ungrouped frequency table. Now, to answer this question you must know your formula. Formulas are given, but it's much better if you know the formulas off by heart. So we need the sum of fx squared and we need the sum of fx. We need the sum of f. Well, the sum of f we can start with is very straightforward. We just total up the f con and we can see that there are 15 bits of data here. We've got 4 frequencies, 4 occurrences of the, let's call it age 5, 4 5-year-olds, 6 6-year-olds, 3 7-year-olds, 2 8-year-olds. So we've got 15 children altogether. So we're going to work out the standard deviation, and that's a measure of the spread of the ages. So we need the mean as part of that. This is actually the formula for the mean. So we need the sum of fx. So the sum of fx is 5 4s are 20, 6 6s are 36, 7 3s 21, 8 2s 16. So if we total that up, we've got 56. 56 and 20 is 76, 77, 77 and 6, 83. So we've got 93. And we need fx squared. So we need to do our x times our fx. I may pick up the calculator to do these. We've got 100, we've got 6 36s, I think I can do that. 6 30s are 180, 6 6s are 36, so I think we're looking at 216 there. 7 21s is 147, and 8 16s would be 8 8 doubles, so we're looking at 128. Now, I will pick up the calculator for the adding up bit, so we'll go there next. So I'm just getting my calculator ready. Okay, and I'll see if we can show you both at the same time. So we'll pull that up and clear this. So off we go. So 100 plus 216 plus 147 plus 128 equals, so we've got a 591. So we have everything we need. I'll clear this and I'll use my calculator to do the rest. So it can be done in one go. So we're doing the square root of, and I'll put in all the parts we need. 591, it's the sum of fx squared, over 15, sum of f, minus sum of fx squared, 591. That would be wrong, wouldn't it? Nearly made a mistake there. Sum of fx, 93. Apologies for that. 93 over 15 squared. Now, this lovely calculator I have here, a free app on the iPad and iPhone. Come around the right way, thank you very much. So we'll pull this back into shot so you can see it. We'll now do the calculation up there. So, open brackets, 591 divided by 15, close brackets, subtract, open brackets, 93 minus, whoops, let's go back one, 93 divided by 15, close the brackets and square. That looks good, let's go with that, and we've got 0.9797, so it equals 0.9797. So if I round it to 3 significant figures, 9, 7, 8, 3 SF. So you can see with the right calculator, and the important thing here is to check your own calculator and see if it works like that. It'd be good to use this example and check that you get 0.978, and then you'll know that you're quite safe at what you do. So we go to the second example now. Then we've got grouped frequency, and I did do a video on this earlier and made a classic mistake, which I'll talk to you through because it's quite easy if I do it, but perhaps you might do that yourself. So we start off with the x, and the x is the midpoint, so that's fairly straightforward. The midpoint of 0 and 10 is 5, 10 and 20 is 15, 20 and 40, so you've got to be awake here. It's not going to go up by 10, it's going to go up by 15 as the interval is larger, and then the 40 to 60 interval will be 50. So when I did this earlier, everything was fine to start with. I did my fx, I did 5 5s are 25, 7 15s, 7 10s, 70, so that's 105, 3 30s, 90, 2 50s, 100. And what I did wrong earlier was I went into sort of a that times that mode, and that was quite wrong because I want fx squared. So that's going to come from multiplying these two. So they're next to each other when we use group frequency, whereas they're apart in ungrouped. So I had to redo the video because I made such a mess earlier. So 5 25s, 125. 30 90s, I can do that one, 2,700. 50 times 100 is 5,000. It's just right over here, 15 times 105. I'll do that on the calculator. So 15 times 105, and I've got 1575. So, and I'll tell you how I also realised, but I did make a mistake, eventually realised, I must say. I'll get my calculator and start doing the column adding ups. So let's get the calculator. So we're going to add up the, let's put the calculator up here, and bring that into view for you. Right, so we're going to add the frequencies. Well, that's pretty straightforward. That's 15. Is it 15? No, sorry, 12 and 5 is 17. We don't need the sum of x. 25 and 1, okay, that's 130. 130, 220, 320. That's quite easy. Probably this one is not too bad. So we've got 125 and 1575. That is 1,700 and 2,700. 44, so I think this is 9,400. We'll add them up anyway just to be sure. You have plenty of time in the exam plus a calculator, so you want to double check your calculations as you do these things. 2700 plus 5,000 and 9,400. So put that into the calculator, so it's 9,400 over 17 minus 320 over 17 all squared. So what went wrong earlier is I got a no answer on the calculator, and that was because this part was larger than that part, and therefore you couldn't get a square root of a negative. So that indicated to me eventually that I had done something wrong, but it was quite awkward finding the mistake. So, right, so let's do this then. I'll put that on the screen so you can see it. So we're doing square root. Open brackets, 94, 0, divided by 17, close brackets, subtract, open brackets, 320, divided by 17, close brackets, square, equals, that comes out as 14, you can see it's 14.09, so that's 14.1 to 3 significant figures. So there we are, there's two examples for you, grouped and ungrouped tables, and just be careful the way you calculate your fx squared, as it's possible to make a silly error in there, what it was for me anyway. Okay, hope that's helped.